Algebra 1, Lesson 111, we are solving problems involving permutations. So we're going to be able to do a little bit of probability, a little bit of combinations with these permutations. So how can you determine all of the possible outcomes in a situation? Well, we have some simple ways. So like if you have 2 pairs of pants and 4 shirts, how many different ways could those be worn? Well, this is the fundamental counting principle, saying if we have independent event M, and it can occur in M ways, and then another independent event N can occur in N ways, the number of ways that both events can occur is M times N. So we would say in this case, 2 pairs of pants and 4 shirts, 2 times 4, there are 8 ways that these can be worn. Or even like this next one, if we have a 1-topping pizza with a choice of 4 different toppings and we have 3 different types of crusts, find the number of ways that that pizza can be ordered. Well, we could say 4 different toppings, 3 different crusts, so that would be a total of 12 different ways. And we can prove this by doing a tree diagram. Let's say we pick the crust first and we're going to say thin. We could have thick, or we could have traditional. And then we could have our 4 different toppings, and I'm just going to label them topping 1, 2, 3, and 4. So we have 1, 2, 3, and 4 for each one of these. So we see we could have 12 total possibilities. We could have thin with the 1 topping, thin with the 2 topping, thin with the 3rd topping, or thin with the 4th topping, and we could do that all the way down, meaning that we will have 12 different choices for this pizza. Okay, now that's for independent events. We have an event that occurs and a different one, and they don't affect each other. But a permutation is a little bit different. We don't have as independent events as before. It's really a group of people or objects that are arranged in a certain order. For example, the number of ways you can arrange 5 different colored books. Now, we are going to use something called a factorial, and we call it n factorial. That's what that exclamation point means. It says it's used to find different ways to arrange a set of different items. And how we calculate the n factorial, what we do is take n and then multiply it by the number before n, and then multiply by the number before that, and before that, and before that, all the way until we get to 1. So for example, if I have 5 factorial, that means I have 5 times 4 times 3 times 2 times 1. We multiply all that out, we end up with 120. So if we have these 5 different colored books, we have 120 different ways of arranging them. The reason we use a factorial is this. Say we have this bookshelf, and there are 5 spots for these books. 1, 2, 3, 4, and 5. Okay, so we have these 5 different spots for the books. Well, if I have these 5 different books, if I put them in spot number 1, I have 5 different choices of books to put in spot number 1, and so I place 1 there. Then when I go to spot number 2, I only have 4 choices now in order to put in spot number 2. 3 choices for spot number 3, 2 choices for spot number 4, and 1 choice for spot number 5. All of these multiplied together give me my 120 choices. Okay, that's why we use a factorial, so that we can see all of those different options for those 5 spots. So let's try this one. If there are n factorial ways to position n students in a line. So if we have 6 students, how many different ways can we arrange them into a line? So instead of n, we say we have 6 factorial, which means we get 6 times 5 times 4 times 3 times 2 times 1. Which gives me, well, we know that 5 factorial was 120, so times 6, so 120 times 6 is 720, I believe. Okay, unless my brain is not working this morning. All right, so let's continue. And we see some other factorials. Now let's just work through some of these. So 7 factorial would just be times 7 to 720, which means we get 5,040. And then we're going to do 9 factorial, which is really just adding a times 8 times 9. And we get a really big number, 362,880. And then we look at these fractions over here. We say 9 factorial over 4 factorial. Now we could say that 9 factorial is 362,880. And 4 factorial is 24. Yes, we could go ahead and divide them, but there is an easier way. Okay, now let's think about what these factorials actually mean. And I'm going to write out some of them. We're going to say we have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. All over, and I'm going to offset this just a little bit so it's even easier to see, we have 4 times 3 times 2 times 1. Which means when we look at these, 4 divided by 4 is 1, 3 divided by 3, 2 divided by 2, 1 divided by 1, which means all we really need to do is this 9 times 8 times 7 times 6 times 5, which gives me 15,120. Okay? And same with the second one here. We have 3 times 2 times 1 on the numerator. And then we're going to have 7 times 6 times 5 times 4 times 3 times 2 times 1, which means the 3's, the 2's, and the 1's cancel out. So I am left with 1 over the 7 times 6 times 5 times 4, which gives me 1 over 840. Okay, so think about making these simpler as you go through rather than keeping them complicated. Okay, I would rather cancel out some numbers rather than dividing huge numbers. Okay, now a true permutation is not just looking at how many different combinations for just these objects. Oftentimes we look at how many different ways can we have these objects and only pick 3 of them. So say we have 6 different options, but there's only 3 spots for them. That's a true permutation. We use this formula to say NPR, okay, N being the number of objects, okay, N being the number of objects, and R being the number of spots that we have for them. So it's used a lot to determine the number of ways N people can win the first 3 places, for example, or N objects can be put into only 3 drawers. Okay, whatever it might be. And so we say that's n factorial over n minus r factorial. So let's try it. And in this first example, kind of silly, but if we have our 6 classes competing in pennies for patience, how many ways can the classes finish 1st through 6th? Well, we have 6 classes and 6 spots for them. So when we plug it into our formula, 6 permutation 6, that equals 6 factorial over 6 minus 6 factorial. Now, big thing here, we definitely know what 6 factorial is. We say that's this 6 times 5 times 4 times 3 times 2 times 1. But on the denominator, we see that we get 0 factorial. 0 factorial is not just 0. It actually ends up being 1. Just like some other funky patterns that we have proved in the past, like how an exponent to the, or a base to the 0 exponent is 1. Just like that, a factorial of 0 is actually 1. Okay, funny, but it is a true mathematical statement. Let's try it now if we still have those 6 classes, but we only are giving prizes to the 1st and 2nd places. So we only have 2 spots for them. So we plug it into our formula, say 6 permutation 2 is equal to 6 factorial over 6 minus 2 factorial. That's really 6 factorial over 4 factorial. And just like on the other page, lots of those are going to cancel out, and we end up with just 6 times 5, or 30 different ways that that can happen. Okay. And once again, 8 people are competing. How many ways can they finish 1st through 8th? I'm going to skip this one. It's just like the 6 classes getting 1st through 6th place. So now that we have those 8 people, how could we arrange them to win the top 3 prizes? So 8 people, only 3 places, so we say 8 permutation 3 is equal to 8 factorial over 8 minus 3 factorial. That's really 8 factorial over 5 factorial, which means all I have to multiply is 8 times 7 times 6, since the rest of everything is going to cancel out. So when we do that, 8 times 7 times 6 gives me 336 different ways of having these 8 people finish in the top 3 places. Okay, and just 2 more examples for you, similar, or I'll just do this one and you can try the other one for yourself. So the 15 members of a team have uniform numbers of 1 through 15. They are introduced randomly. What's the probability that the first 4 players introduced will have uniform numbers of 1, 2, 3, and 4 in that order? So this is a probability. So we need the choice that we want out of the total possibilities. Now the choice that we want is the number of ways to choose 1, 2, 3, and 4. Now how many different ways can we choose 1, 2, 3, and 4 in that order? Well, there's only one way to do that. And then, so that's my one choice that I am okay being successful with. Just like if I wanted a number 2 on a number cube, okay, out of our 6 different possibilities, I would say 1/6. Now our total possibilities here is the number of ways to choose 4 numbers, those 4 numbers out of our 15 total, which is really our permutation of 15 total people, permutation, and we're picking 4. Which means I'm going to be doing 1 over, and then I do this permutation, which means I'm going to do 15 factorial over 15 minus 4 factorial, which is 1 over, well, I have 15 factorial over 11 factorial, meaning that all I'm going to have to multiply together here, since everything else cancels out, I have 15 times 14 times 13 times 12. All the others cancel out. And when I get that, I end up with my denominator just being 32,760. And we still have our numerator of 1. What this means is that out of 32,760 different ways to choose those 4 numbers from the 15 people, only one of them will make me successful. That is a very, very low probability. It is highly unlikely. Okay, still possible, but very, very unlikely. Here's one last problem that you can try, very similar to what I just did, so try it out on your own. Going to be a little bit better probability, but not by much. All right, well, I hope this helps for your homework and for studying.